We solved some questions about resistors in parallel and series, and also about Kirchhoff's law. The first question, the following figure shows network of resistors connected to a cell of EMF 6.0 volt. Show that the resistance of the network of resistors is 40 ohm. We need to find the combined resistance or the total resistance of the network. Now, first of all, 40 and 20, they are connected in series. Then we find R total of them. So, this is part A. The total resistance of 40 and 20. Let this denoted by RT1. So, RT1 of 40 and 20, because they are in series, so it's 40 plus 20 equals 60 ohms. Then you can replace this by 60 ohms. Now, 60 and 40, they are connected in parallel, equals 1 over 60 plus 1 over 40, all to the power negative 1. We use the calculator to get the answer. 24 ohms. Okay. Now, what is R total of this connection or this branch? So we find R total 2 of this one. Let this is R total 2. You can say they are connected in series. 24 and 90. 24 and 96 are connected now in series because we can replace this by 24 ohms. So R total 2 is 24 plus 96. The answer is 120 ohms. Then R total for the whole circuit equals 1 over 60. Again, remember, the combination of 60, 40, and 96 is 120 ohms. Then R total for the whole circuit is 1 over 60 plus 1 over 120, all to the power negative 1 because they are in parallel. The answer is 40 ohms. So this is the first part. So, show that the resistance of the network is 40 ohms. Now, calculate the current in 60 ohm resistor. Here we have the voltage, it is 6 volt. Because we have parallel connection, so 40 and 60, 40 and 20 takes 6 volt, and also this combination takes 6 volt. Then the voltage is 6 volt, and the total resistance RT2 equals 120 ohms. So in part B, we use Ohm's law. Vi times R. We can calculate the current I. The current I equals V over R. V equals 6 volt. R is 120. The answer is 0.05 ampere. Where is that current? This is the current here. So it is 0.05 ampere. Also it's here 0.05 ampere. Because we have the current and we have the resistance, we can find the voltage V1 across 96 ohms. Then V1 equals I multiply R1. I is 0.05, R is 96. The voltage across 96 ohm resistor is 4.8 volt. The total voltage is 6 in that branch down. Then the voltage here denoted by V2, it is V total minus V1. V2 according to the parallel resistors 60 and 40 equals V total minus V1. V total is 6 volt minus 4.8. The answer is 1.2 volt. Then, because 60 and 40 are parallel, then they have the same voltage, which is 1.2 volt. Now we can calculate the current in 60 ohm resistor and also the current in 40 ohm resistor. Let this current denoted by I1 according to 60 ohm resistor. It's V over R. The voltage now is 1.2 and the resistance is 60. So 1.2 divided by 60, the answer is 0.02 ampere. To check our answer is correct or no, we can find the current in 40 ohm resistor. The voltage divided by R, the voltage is the same and the resistance is 40. So 1.2 divided by 40, it is 0.03 ampere. Note that the current in 60 ohm resistor is 0.02 plus the current in 40 ohm resistor is 0.03 equals 0.05 ampere, which is the total current in the branch. Then our answer is correct. In the electrical circuit shown, each cell has EMF 1.5 volt. How many cells we have? We have 3. So this cell is 1.5 volt, this cell is 1.5 volt, and also this 1.5 volt. Has negligible internal resistance. The voltmeter reading 1 volt. So the reading here is 1.0 volt. Now, state the direction of the current in the circuit. This one is positive and this one is negative. Then we can say this is a battery of 3 volt. And this is just one cell of 1.5 volt. Then the current goes from higher voltage to the lower voltage, from 3 volt to 1.5 volt. Then this is the direction of the current in the circuit. It's clockwise. Then the current in the circuit is clockwise direction. In part B, calculate the value of the current. Because we have the voltage 1.0 volt and the resistance is 10 ohm, so we can calculate the current. Remember Ohm's law, V I times R. Then the current equals V over R, which V is according to 10 ohm, not 3 volt, not 1.5, it's 1 volt. So it's 1 over R. R is 10. Then the current is 0.1 ampere. So this is the current in the circuit. The current in the circuit is 0.1 ampere. Part C, calculate the resistance R. Now we apply Kirchhoff's second law. So this is the direction of electron flow. This is the direction of electron flow. And then we start from one corner, this corner, for example. And then we go around this to return back because this is closed loop. Kirchhoff's second law, we start from this corner. So the total voltage here is 1.5 because the direction of electron flow is the same direction of current in the loop. So it's a positive 3 volt. And then the current is 0.1 and the resistance is 10. So it's a minus IR 0.1 multiplied by 10. Now the direction of current in the loop is opposite to direction of electron flow. So it's negative 1.5 volt. Last, the resistance is R and the current is 0.1. So it's negative 0.1 multiplied by R. We reach to the point here, then the answer is 0. So 0.5 minus 0.1 R equals 0, negative 0.1 R equals 0, negative 0.5. Cancel negative with negative, then R equal 0.5 over 0.1, which is 5 ohm. Find the current in 12 ohm resistor in the following figure. First step, we need to find the equivalent resistance of the whole network. Then, we're starting the solution to find the R of 6 and 6. This parallel combination, 1 over 6 plus 1 over 6, all power negative 1. It is 3 ohms. Then we can replace 6 and 6 by just 3 ohms. Also, we find R of 4 and 12. They are parallel. 1 over 4 plus 1 over 12, all to the power negative. It is 3 ohms. Then we can replace 4 and 12 also by 3 ohms. Now, the total resistance of this branch, 3 plus 3 is 6 ohms because they are series now. And also for this combination, 3 plus 2 is 5 ohms. Then R total for the whole circuit equals 3 ohms, they are in series, plus open bracket 1 over 6 plus 1 over 5, all power negative 1. The total resistance is 5.73 ohms. Use Ohm's law for the current V I R. Then the total current from the circuit, then the total current here from the circuit I equals the total voltage over the total resistance. So it's 18 divided by 5.73. 3.14 ampere. From this current, we can calculate the voltage drop through 3 ohm resistor. So V1 equals I multiply R1. I is the current 3.14, R is 3. The answer is 9.43 volt. Then this combination, all of them has V2. So V2 equals the total voltage minus V1. The total voltage in the circuit is 18. V1 is 9.43. The answer is 8.57 volt. In that combination of resistors, we have the total resistance 5 ohm and the total voltage 8.57. Then we can calculate the current. Let this current denoted by I1. So I1 is V over R. V is 8.57. R is 5 ohms. The answer is 1.71 ampere. So the current here is 1.71 ampere. We can calculate the voltage around this. Let this denoted by V3. So V3 equals I multiply R. What is I? It's 1.71. What is R? It's 2. The answer is 3.43 volt. The total voltage is 8.57 in that branch. Then we can get the voltage according to this parallel combination. Let it's V4. Then V4 equals 8.57, it was V2, minus 3.43. Then the voltage across 4 and 12 ohm is 5.14 volt. Now we can calculate the current in that. Because 4 and 12 are in parallel connection, they have the same voltage. Then the current equals V over R. V is 5.14 over R over 12, 0.43 ampere. To check your answer, you can get the current in 4 ohm resistor. It's 5.14 divided by 4. The answer is 1.29. To check your answer, if you calculate 1.29 plus 0.43, it will be 1.71 ampere, the same as we got before this current. Next question. For the circuit in the following figure, calculate the equivalent resistance. How can we decide the resistors in parallel or in series? If the current split into I1 and I2, so it's parallel. If the current is the same, it will be series. Now, here, the current here, can you see? It is the same current in that branch. Then, that resistors are in series. Then we add them. Then 3 plus 4 plus 3 equals 10 ohms. We can replace all of these by 10 ohms. Then we can redraw this in this formula. This is 10 ohms and then connected to 10 ohms. This is A, this is point A. Here 10 and 10 are in parallel connection. Then R total of them 1 over 10 plus 1 over 10 all to the power negative 1. The answer is 5 ohms. Then we can replace that all by 5 ohms. Then we have this combination 3 ohms. This is 5 ohms. This is 2 ohms. They are in series. 3 plus 5 plus 2 equals 10 ohms. Then we can say this is 10 ohms and this 10 ohm. They are connected in parallel. Then we find our total 1 over 10 plus 1 over 10 all power negative 1, it's 5 ohm. Then we replace all of that by just 5 ohms. Now our total, it's easy now. So this is 5 ohms and the total is 5 ohms, and down we have here 4 ohms. Finally, this is the cell which is 28 volt. Now we can get our total. They are connected in series. Then for part A, our total equals 5 plus 5 plus 4 equals 14 ohms. This is our total. What about part B? The power dissipated by the entire circuit. Here we have the voltage and we have the resistance. Then which formula for the power? V squared over R. V is 28 squared over R over 14. The answer is 56 watt. Part C, find the current in 5 ohm resistor. We need the current here in 5 ohm resistor. This current comes from the cell, so it is total current. How can we get the current? Remember Sambusa law, V equals IR. Then the current equals V over R. V is 28 and the total resistance is 14. So the current is 2 ampere. Then the current in 5 ohm resistor is 2 ampere. Then the current in 5 ohm resistor, it's 2 ampere.